In this inorganic chemistry video, we're going to discuss on chapter 5 on group 1 alkali metals. We're going to discuss the introduction on group 1, the physical properties, and the metal preparation for sodium. Group 1 consists of lithium, sodium, potassium, rubidium, cesium, and francium. So the element is also called as alkali metals. So the metal is soft and having a silvery color. So if you look to the image here, from lithium to cesium, it having a silvery color, but for francium, it having a slightly brown color, and francium is a radioactive element. So group 1 located at the very left side of periodic table, and it is the most reactive of all metal, reacting readily with air and water. So the valence configuration is NS1. Alkali metal lose electron to form +1 ions and forming an ion such as Li plus or Na plus. The lithium abundancy at Earth crust is only 0.0018%. It is very less, and the mineral source for lithium is spodumene, which is LiAlSiO3. There is several others mineral resource including petalite. It is LiAlSi4O10. This is also one of the mineral source for lithium metal. So for sodium, the abundancy is higher compared to lithium, in which 2.27%, and the main mineral source is rock salt, or this is our table salt. Several other minerals including cryolite. It is a Na3Al(F6). So for potassium, the abundancy is 1.84%, and the mineral source including silvite or KCl. So other than silvite, there is a mineral source like carnallite, in which it is a KCl, magnesium chloride, 6H2O. For rubidium and cesium, the abundancy is very less, 0.0078 for rubidium and 0.00026% for cesium. There is no convenient source for these two metals. Typically, rubidium and cesium is obtained by the byproduct processing of lithium metal. For lithium, sodium, and potassium, it is stored in oil. So this is to prevent the reaction of metal with oxygen and also air. For lithium, it having the atomic number of 3 and the electronic configuration of helium 2s1, or we can write it as 2,1. For sodium, the electronic configuration is 2,8,1. For potassium, 2,8,8,1. For rubidium, 2,8,8,1. For cesium, 2,8,8,1. And for francium is 2,8,8,18,32 and 1. So if we can see on the electronic configuration, so the outer orbital having one electron. So this one electron is readily to be removed to form an ion. On its physical properties, as a general rule, when downing a group from lithium to cesium, the atomic radius is increasing from 1.52 for lithium to 2.65 angstrom for cesium. So the same observation is also recorded for ionic radius, in which for lithium is 0.76 angstrom and for cesium is 1.67 angstrom. On the melting point and boiling point, so the trend is that the melting point is decreasing from lithium to cesium. Similarly, for the boiling point is also having a decreasing trend. So it is because as the orbital increase, the shielding effect is more dominant. So one electron that occur at the outer side of the electron is having less attraction from the nucleus. So that one electron is easier to be eliminated, and then making the melting point and boiling point decrease. Regarding the first ionization enthalpy, or the energy is needed to eliminate the first electron, so we can observe that the energy is also decreased, meaning that the energy to eliminate one electron from lithium is higher compared to eliminating one electron from cesium. So this is also can be discussed as the attraction of nucleus to the electron in lithium is higher compared to cesium, making that energy required to eliminate electron from lithium to forming Li plus is greater than Na plus and K plus. So regarding the electronegativity, it is decreasing from lithium to cesium. The density is increasing. For lithium, sodium and potassium, it is having a density smaller compared to water. So it will be floating on top of water. About its standard potential and hydration enthalpy, so the value is also increasing. To further understand about the first ionization energy, so let's say we consider of lithium. So lithium having the electronic configuration of 2,1. So meaning that, let's say this is the nucleus of lithium. This is the first orbital, and this is the second orbital. So it's not really nice. So I redraw it again. So here is the second orbital. So in lithium, the first orbital consists of 2 electrons. So we have 2 electrons here on the first orbital, and the second orbital having only 1 electron. And to make it into ion or elimination of 1 electron, so again, here is the nucleus, the first orbital. So now, in lithium, after elimination of 1 electron, So we eliminate one electron, in which this is the electron that been eliminated from lithium. So lithium became Li plus with the electron of 2. So let's consider on sodium with the electronic configuration of 281. So I will make it further down for easier drawing. So Na, we have electronic configuration of 281. So we have the nucleus, the first orbital, it's okay, the second orbital, and the third orbital. So in sodium, the first orbital consists of 2 electrons, the second orbital having 8 electrons, 2, 3, and the outer orbital having 1 electron. To make it into ion, or elimination of 1 electron, so it will be becoming Na plus with the electronic configuration of 2, 8. So here we have the nucleus of sodium, first orbital and second orbital. It's supposed to be a circle. Okay, 2 electron on the first orbital and 8 electron on the second orbital. This is to complete the octet. One, two, three, 4, 5, 6, 7, 8. Okay, now in this case, what happened is that the electron, the outer electron in lithium is closer to the nucleus. So the attractive force between nucleus and the electron on the outermost shell is stronger compared to the sodium, in which the length of electron on the outer shell to the nucleus is became longer, so that the attractive force between nucleus and electron on the outer shell is weaker compared to lithium. So for sodium, the energy is required to eliminate 1 electron is smaller compared to lithium. The typical preparation of metal in group 1 is by electrolysis. So in this part, we will discuss on sodium preparation by electrolysis of molten sodium chloride. So the molten sodium chloride is in liquid state, and the reactor is called as down cell. So in the reactor, we have the inlet for sodium chloride. So we have positive electrode, carbon anode, and negative electrode, iron cathode. So by the passage of voltage, as sodium chloride will form sodium ion Na plus and Cl minus, the reaction of electrolysis will happen as follows. As at anode, so we will have the reaction of chlorine gas, Cl minus, became chlorine gas and production of 1 electron. So in this case, oxidation reaction took place, as the equation is not complete. So here we have 2 electron and 2 mole of chlorine ion. At cathode, so we will have Na plus it will be Na plus, it represent of electron, it will be sodium metal. So the overall reaction is as follows. So for overall, so to make it easier to eliminate the electron here, we need to balance the cell. So we have 2, 2, and 2, so that we can deduct the electron from anode and cathode. So we will have here 2Na plus plus 2Cl minus, it will become 2Na metal plus chlorine gas. So the chlorine gas will be collected through a chamber, whereas the liquid metal will be collected on another chamber. So this is how industrial method for sodium preparation. For further detail, you might want to look to another resource such as YouTube listed here. So with that, thank you.